Welcome to the CADFEM ANSYS tutorials. In this presentation, I would like to show you how you can incorporate changes in the CAD system into the ANSYS finite element calculation in order to improve your product design. In the first two presentations, we had a look at this corner component, looking at how to calculate stress and deformation and how to verify the quality of the mesh. And we established that the component is deformed by 0.32 millimeters and exhibits stress equating to 280 megapascals. The area of maximum stress is located here in the rounded area, and if we had a requirement to reduce these stresses to values of less than 200 megapascals, then one particular procedure for modifying this rounded area would suggest itself. This involves changing into the CAD system and looking at the rounding. This rounding is currently modelled using a value of 5 millimeters. We alter this value to 8 millimeters, regenerate the model, and we can now transfer this into ANSYS by selecting Geometry from the tree directory, and then updating the altered geometry by selecting Update Geometry from Source using the right mouse button. Once this change has been loaded into ANSYS, the tree directory in ANSYS is updated, and we can once again check the loading condition. The forces and the loading condition remain as they were. The mesh settings are also unchanged. Of course, we have to regenerate the mesh. If we want to check it before performing an analysis, then we can see that the radius of the rounded area is greater, and the mesh has been correspondingly refined within the defined area, and we can begin the calculation. When the calculation has finished, we can look at the result once again, and we see that the stresses have decreased from 280 megapascals to 235 megapascals. So we do indeed see an improvement, but it's not yet the great improvement we were looking for, which means we should consider some other modification that would lead to a reduction in stress. So what are the possibilities? Well, we could add a strut here in this central region, in this critical area, to increase the stability of this component and to minimize the stresses. So we model our strut in the CAD system. We model the rounded edges, and once again we have an alteration which can be loaded into ANSYS, just as before. So we activate ANSYS, select Geometry from the tree directory. Then, using the right mouse button, we select Update Geometry from Source, reloading the geometry into ANSYS. And again, the loading and boundary conditions remain as they were. We could immediately perform a calculation or check the mesh, selecting Generate Mesh. The mesh now contains refinements in certain places, but it makes sense to include the peripheral areas. So we alter the number of selections to be included in this localized refinement process by once more selecting these 6 faces, and then adding these 2 surfaces here at the edge, and then beginning the analysis. Or perhaps it's preferable to check the mesh again. Yes, so far that looks reasonable, and then we start the calculation. So let's take another look at the stresses. We see that the stress has gone down to 174 megapascals. Just to complete the picture regarding the quality of the mesh, it's now sufficiently accurate for production of a reliable stress report. Once again, let's compare the stresses that have been averaged out with those that have not. When the values are virtually identical, we have fulfilled the criterion of being able to ascertain that the mesh is of sufficient quality, sufficiently accurate for production of reliable reports. Instead of this manual comparison of alternative options, you could also carry out a systematic variation in design. More of that in the next presentation.